This is a question which lumps your knowledge of roots of cubics with logs. Let's go through it step by step and find out what's going on. Right, we've got this cubic and we're told that f minus 6 equals 0. Well, if that's true, then we've got x plus 6 is a factor. This is by the remainder theorem. What it means is if I shove in x is equal to negative 6 throughout this equation, it generates 0. Now we've got to show that a is equal to 4. So to answer part 1, all we've got to do is substitute x is equal to negative 6 into fx, which we know is equal to 0, and solve for a. So therefore, negative 6 times negative 6 times negative 6 is negative 216. Negative 6 times negative 6 is 36, so this is plus 36a. Negative 6 multiplied by negative a is plus 6a plus 48, and that equals 0. So therefore, gathering up all the a terms, 36 plus 6 is 42a, is equal to 216 minus 48. So therefore 42a is equal to 168, and therefore a is equal to 168 divided by 42, which indeed is 4. So we've proved the first answer. Still no sign of logs yet, as we're asked to express f of x as the product of two algebraic factors. So given that we know that x plus 6 is a factor, if I take x plus 6 out of this cubic, I will generate a quadratic. So this is equal to x plus 6 coming out as a factor, leaving a quadratic, and we don't know any of the coefficients of that quadratic, so I have to write the general form for quadratic, which is ax squared plus bx plus c. A and c are really easy to find. Look at that multiplication and look at that multiplication. X multiplied by ax squared is the only time we will get an x cubed term, and we know the coefficient of x cubed is 1. So I can say, therefore, a is equal to 1, and c, well, 6 multiplied by c must give us 48. So c is equal to 8. So how do we go on to find b? Well, the combination of all the multiplications here must generate the whole of the equation. So if you look to what terms actually generate an x squared term, we need that coefficient to be 4. So I start with 4x squared. That's what we need to find. X times ax squared generates an x cubed term out. X times bx, yes, that does generate an x squared term, and it becomes bx squared. X times c, no. Now we try the 6. 6 times ax squared, yes, that does generate an x squared term, and it's 6a x squared. Then we go on, nothing else should work, but let's just check. 6 times bx, no, that generates just an x, and this generates a number. So we've got an equation here in x squared, and the x squareds, in fact, disappear. We can divide through by x squared. Therefore, we get 4 is equal to b plus 6 times a, which is 6. So therefore, b equals negative 2. So our quadratic here, which are two multiplying factors of fx, we've just got to substitute these three values in. So with room running out, I can say that fx is equal to x plus 6 multiplied by a is 1, so this will be x squared, b is negative 2, so this is negative 2x, and c is equal to 8, so this is just plus 8. And that is the answer for part 2. Okay, let's have a look at B. Yes, quite a lot of work, and we're still only halfway through. Given that that lot, a log equation equals 3, so that we get back to our original equation. Okay, well, let's try that. This is now the application. At last, something about logs. Okay, now we can apply the log laws. This first term has got a 2 in the front of it, so we can say this is log of x plus 2 squared, and then we can apply both the multiplication rule and the division rule. So let's try to do those both operations together. This will be x plus 2 squared, then it'll be multiplied by the x, and then it'll be divided by x minus 6, but it's all one big log term. So therefore I get log to the base 2 of x plus 2 squared multiplied by the x and divided by x minus 6. And this is equal to 3. Now we take antilogs with respect to base 2. So this 3 will be sat as an index on top of the base 2, and the antilog of this side, the log will just effectively disappear. So therefore we get x plus 2 squared divided by x minus 6 equals 2 raised to the power 3, which is 8. Okay, multiplying through by x minus 6, I get x plus 2, and I'm going to write that twice because I know I'm going to be multiplying out, is equal to, and I'll multiply this out, so I get 8x minus 48. So therefore, multiplying these brackets out and each term multiplying it by x, I get x cubed. Now the underneath, this is 2x, this is another 2x, so it's 4x, but we multiply it by x, so it's plus 4x squared. 2 times 2 is 4, multiplied by the x, so this is 4x, and that's equal to 8x minus 48. It's looking remarkably close to what we're supposed to get. Therefore, gathering terms up again and shoving everything on the left, I get x cubed. X squareds, well, the only x squared term is plus 4x squared. 8x comes across, becomes negative, and adds to the 4x, and we get negative 4x plus 48, and that's equal to 0. And we've proved it as required. Now this question about roots. Well, from the previous question, we know that fx, when we split out that factor of x plus 6, is equal to x plus 6 multiplied by the quadratic we got, which was x squared minus 2x plus 8. So we know, therefore, that x is equal to negative 6 is a root. But does that work in our log expression here? The log of a negative number is undefined. So if x is negative 6, this indeed is a negative number, negative 4. So that term won't give a result, that term won't give a result, and indeed that term won't give a result. So that is not a solution 2. But what about the remaining quadratic? Would there be a root here? Well, the rule for testing that is to test the discriminant. That's the bit underneath the square root sign in the quadratic formula. If this turns out to be negative, the quadratic here also offers no real roots. So let's try it. B squared, negative 2 times negative 2 is 4. Now, is this term going to be negative? A and C are both positive, so no, this is going to be negative. 4 times A is 1, 4 times 8 is 32. So this gives an answer of negative 28, which is less than 0. And as in the quadratic formula, we have to take the square root of b squared minus 4ac. We can't take the square root of a negative number, or any number which is less than 0. So it means there are no real solutions from the quadratic part of the equation. So my conclusion is that Therefore, our friend up here has no real roots. And that's your answer.